Hello YouTube, how are you doing? So I was not planning to make a video today because it's so windy over here and I'm just swaying from left to right, but this topic will sway you from left to right because it's about the swarm robots that work together in a herd, and then concepts of herd mentality can be true, but I won't go that far. Robot market itself with the RISC-V is growing pretty heavily, but RISC-V is something that is important within a chip perspective because it is the essence of the computation behind robotics, or more, can be more in the future. So right now the growth of RISC-V is 1.4 billion in 2025 to 7 billion by 2030. That's a CAGR of whopping 38%. $1.4 billion, right? So it powers AI systems, robotics, and industrial automation. So I have some of my notes here, so just want to make sure that I give you the best information, and the notes are from my original post that I'll include in this video, which is on LinkedIn, right? So the point I wanted to make over here is that GPU are very power consuming, right? And they are expensive, and there are a lot of things happening with them, and supply chain can be an issue also going forward, although I am not strongly predicting it right now. They consume, if you actually take NPU, neural processing unit, and AK AI accelerator and pair it up with a RISC-V CPU core, you get a very manageable and moving system that can actually power autonomous vehicles and robots in even underwater vehicles. Now let's talk about software portability, because robots, RISC-V, NPU. What do we run over there from an AI perspective? So YOLO is a model that we run, and YOLO V5 is the latest one right now, at least that I have seen, and it is object detection. And the compilation is easy because you can compile it with lightweight inference libraries, right? And that would be TVM, TF-Lite, and they run on RISC-V, and combined with NPE, you can go without GPU dependency. Did I hear it right? Yes, you heard it right. Well, most of the time, not all the time. So let's say you can take a quantized model and you can detect obstacles in a drone system, and then run that directly on the drone's RISC-V NPU, and that will eliminate, from edge computing perspective, the cloud latency and power and the cloud costs. I want to bring up another piece over here in the system puzzle. RISC-V NPU we have the software library statement, and then we have model YOLO V5, and the other thing is another piece of hardware, which is FPGA, which is used in autonomous vehicles as a watchdog essentially. And watchdog means that FPGA is very malleable. You can program it to become an AI accelerator. Also, it is so malleable that you can download software on it, while half of it can be you doing something, execution activities over there. And autonomous vehicles usually have it in their system as basically security safety mechanism, because if your chip crashes or your board burns out with thermal issues, then of course FPGA, and saying that not everything doesn't burn out, and FPGA can take over and at least gracefully shut down, although you can do a lot of other features. And I get excited over here because this is a system and the software at play over here. So some of the architectures in play, we have semi-dynamic serval product, which is a flexible RISC-V and NPU IP tailored for edge AI. Then I actually researched on Marcellus SoC, which is another amazing product, which RISC-V DSPs with dedicated DNN accelerators. And the most important thing is that they can reach from a performance perspective of 12 TOPS per watt. And I think we should be also measuring things more from energy perspective now. So especially with robots and other vehicles, and they have to be very energy efficient. So 12 TOPS per watt, merciless SoC, RISC-V DSPs with dedicated DNNs. Aero Accelerator is another FPGA, delivers up to 70 times more inference over scalar CPU cores. Now, what is the strategic advantage over here? You have software portability, you have modularity, and then you have resilience. Combine NPU compute with FPGA, Guardian, and swarm logic, multiple robots connected to each other, and you can get robust, scalable robotics fabric. So things get amazing now from here, and a much better scale. But it's 6 minutes already. Hope you're not getting bored over here. But bottom line is that swarm robotics, I will call it swarm robotics, multiple robots working as a group, doesn't need data center grade GPUs. Well, again, most of the cases, unless you need to make really heavy computational decisions, which becomes non-real time, parking them or just pausing them, probably for fuel, I don't know. So this is amazing. And so the last thing is RISC-V open nature gives you basically the rocket fuel, and then you have the rocket itself, the NPUs accelerators with the engine software as software portability pair with safety layers, and you have next gen autonomy. So here's your autonomy in 7 minutes, 17 seconds almost. Fahad here, again, ex-Amazon, Broadcom, Johnson & Johnson, and I have deep AI infrastructure experience. I have experience running AI inference on multiple computational devices. I have a lot of experience with Rocky, RDMA over converged Ethernet, InfiniBand, FPGAs, GPUs, CPUs, AI accelerators. And your tech lead. You're highly technical tech lead who knows business and industry. That's how I'll sum it up. If you ever want to connect, just send me a message or DM, and I'll see you later with another industry analysis. Take care.